Most people don't fail this problem because it's hard. They fail because they read it wrong. You're given a string. Looks random, but hidden inside it is a perfect grid. And a diagonal pattern. Miss that? You're stuck. See it? You solve it in minutes. And today, I'm going to make sure you never miss this pattern again. We're solving LeetCode 2075. Decode the Slanted Ciphertext. Here's the idea. You're given a string encoded text and a number rows. Your job, reconstruct the original message by reading it diagonally. The string is not random. It was written into a matrix row-wise like this, then encoded by reading, top left diagonal down right. Key insight is, if you don't see the matrix, this problem feels confusing. If you do see it, this becomes a clean traversal problem. Let that sink in. Example walkthrough. Let's say, encoded text equals CHIEPR. Rows equals 3. First question, how many columns? Calls equals len, encoded text, / rows. We reshape into ch underscore IE, underscore PR. Now decoding rule. Start from each column in top row, go diagonally. Walkthrough. Start at column 0. CIR. Start at column 1. HE. Start at column 2. Underscore or skip spaces later. Combine. CIPHER. Then remove trailing spaces. Wait, we're not reconstructing the matrix explicitly. We're just simulating diagonal traversal using math. That's the trick. Brute force approach. Brute force thinking. 1. Build full matrix. 2. Fill row-wise. 3. Traverse diagonally. Problem. Extra space ON. Unnecessary work. Time complexity. O of n. Space complexity. O of n. Works, but not elegant. Optimized solution. We don't need a matrix. We can directly compute. Index equals I asterisk calls plus j, where equals row, j equals column. For each starting column, move diagonally, row plus equals 1, call plus equals 1, until bounds break. This is a classic. Simulate 2D traversal using 1D indexing. You'll see this again in matrix flattening, zigzag traversal, grid simulations, class solution, def decode ciphertext, self, encoded text, str, rows, int. If rows equals 0, return, n equals len, encoded text, calls equals n divided by rows. Result equals hashtag traverse starting from each column. 4 start underscore call in range calls. Row call equals 0 start underscore call. Hashtag move diagonally. While row less than rows and call less than calls. Index equals row asterisk calls plus call. Result.append, encoded text, index, row plus equals 1, call plus equals 1. Return, dot join, result, dot or strip, code breakdown, 1. Calls equals n divided by rows. Converts 1D string virtual matrix. Critical step. 2. Outer loop for start underscore call. Each column is a new diagonal start. 3. While loop diagonal traversal. Moves like 0, C, 1, C plus 1, 2, C plus 2. 4. Index equals row asterisk calls plus call. Converts 2D 1D. This line equals entire problem. 5. Or strip. Removes trailing spaces. Common beginner miss. Common mistakes. 1. Forgetting to remove trailing spaces. 2. Miscalculating columns. 3. Trying to build matrix unnecessarily. 4. Mixing row/column indexing. Pause here. Try writing this from scratch. If you can, you've just built real pattern recognition. Why interviewers ask this? They're testing. 1. Can you convert 1D left-right arrow 2D mentally? 2. Do you see patterns in disguised problems? 3. Can you avoid unnecessary space? Common follow-ups are, What if diagonal is reversed? What if uneven rows? Can you encode as well? Say this: I treat the string as a virtual matrix and simulate diagonal traversal using index mapping. That sounds sharp, clean, confident. What weak candidates do: panic and build matrix, get lost in indexing, miss diagonal pattern. What strong candidates do: identify structure quickly, reduce problem to traversal, optimize space. This problem isn't about strings. It's about seeing structure inside chaos. Today you learned 1. How to map 1D to D. 2. How to simulate diagonals. 3. How to simplify instead of overbuilding. And trust me, this exact thinking shows up everywhere. If this clicked, you're not just solving problems anymore. You're starting to think like a top engineer. Comment: did you see the matrix immediately or later? And if you didn't, that's exactly why we practice. See you in the next one.